All right. Things are going to get really annoying in here really fast once you guys start doing the demo. So I'm going to try to go over everything beforehand, even though I would like to do it like in the middle. The reason why we're doing this is because digital, where a signal starts digital and gets converted to analog, it's lame. It's just not cool. Analog, look, this you can't tell. That's so much cooler. We're doing that one today. That's what they made computers look like in movies. Okay. It's just a schematic. I'll show you, I'm going to show you, walk you through on Falstad, a circuit simulator that you should use because it slaps. And I'm going to walk you through the general idea here. There's only 4 transistors in the entire oscillator. I've done the amplification separately so that, because amplification sucks and it's hard to deal with like efficiently. So you have these little amplifiers. One of the pins, the far left pin is ground, and the far right pin is power, and then the middle is the signal. I can help you out with that if that becomes a problem. If your light turns off on your little power supply there, you've done it the wrong way, and you should do it the other way. So this is new blank circuit. So the main thing that we're going to be dealing with today is a pair of transistors that is called a programmable unijunction transistor. It looks like this. You have an NPN and a PNP, and you have an NPN and a PNP, and then, okay, we're being weird today. And it acts more like a switch than a normal transistor. The 3 leads are, there's one here, there's one there, and then there's the output there. The output we're tying to ground for reasons that will become obvious. So the way that this works, if you have like a 1000 ohm resistor going in here, okay, and then put a voltage source here. I'm going to say this is going to be 2.5 volts. And then we put a bigger resistor on this side, say 100K. And then we give it some juice. We give it I'm going to put a variable voltage right here. Inputs and sources, add variable voltage so that we can slide it around. As you can see, at the moment, the voltage right here at this wire, low. It's at the transistor's cutoff point at the 0.7 volts that it does that. And then if you lower the voltage, there's a point where it stops switching. And it's when it gets below that 2.5 volts from earlier. You go up to 2.5 volts, you go a little bit over, it's over 0.7 over that, and it switches off. This is very useful for what we are going to do today. Instead of having, so we don't have multiple power supplies. So if we want to use this, we can't do this. Instead, we have to make a strong signal that has that same impedance there. So what we do is we do an NPN transistor going in here, and it's following the voltage in the same way that it did in the LED sensors lab. And then we put a 5 volt there because we only have 5 volts. And then this goes into a voltage divider here, going to ground and 5 volts. This top guy is, let's see, 4.3K. And the bottom guy is 1.8K, because that's, a lot of these resistor values are very specific. We use I'm using these specific values for a combination of reasons. One is that we have more of some values in stock in the club room, so it's easy. And the other is that a lot of these are very carefully tuned over multiple days of failing to make this work. So you have to use the right ones. All right. And then, yeah, we got you there. And then, so we have this switch now where the voltage is at a certain low level. And then if you put it above that threshold, it drops down to 0. So all you have to do to turn this from just a switch into an oscillator is add a capacitor here to be charged. Let's say this guy is 100 nanofarads. And then you add a resistor up here. I'm going to do $330K. Then same 5 volts in power. I speed up the simulation speed. Oscillating. You can see that oscillation. If I go view a new scope, see the little wave there. The max value of that wave is 1.3 volts, which is consistent with what we see over here. Because if we take the wire out from, if we look at this wire, it is at about 1.3 volts. Consistent with what we would expect. If you want to look at exactly why this, so then, yeah, this resistor charges the capacitor and then it gets drained out through this switch here. But yeah, this works the way it does and requires that like mildly high impedance signal on this input because it's weird, but in the instant while it starts discharging, it has to have a positive feedback loop going through there. And so this voltage has to get changed. It has to jump down a little bit. And yeah, it's weird, but all you really have to know is that this thing acts as a nice threshold, which makes it very useful for this specific task. Then this here is, I mean, it's a wave, but it's not a very strong wave. If I put any kind of resistor on it, and dead. If I put 100K, see if it dies. It's dead. That's it being dead. So what you have to do is you have to amplify that signal. Let's go. So you have to amplify it here. So you go here, another NPN transistor. You can tell I like these in voltage follower mode. And then here, we can put a much bigger load on it. And it's still working. You notice it's a little bit taxed, but like barely. And so it's not killing it like it was before, where it just like died immediately. So this is our oscillator circuit. I have these little amplifiers over here so that you can just put it straight in and make sound. I'd recommend the first thing you do with the amplifier is you plug it in to power and ground, and then plug in the signal wire and hold it a little bit, and just hear the noise from yourself. It's very entertaining. And it's just like you can tell because you're like an antenna and a capacitor. It makes a bunch of noise, so that's fun. And it also tells you that the speaker's working, and you can call me over and yell at me. Yeah. Then here's the other cool thing. This resistor, if we turn up the resistance to 400K, slightly lower, it charges slightly slower, and you can turn that up and up and up until it's way, way lower, and then you can make it way smaller. And it is a lot faster. So all that we have to do to do that, that resistor value, I've tuned it so that it is equivalent to pencil. If you draw a pencil on this piece of paper, clip on a clip here, you can replace the resistor with these and a little wire connected to ground. And then you have a little electronic string instrument. So the rest of this we'll be playing with toys. Yeah, each of you, like I have it laid out. I can just tell you when you get up here. There's 8 like things, so we got to split into groups, 8 groups or less. I don't care. All right. Big
Yeah, we'll be in the group.
I don't got a good Italian.
Actually, I'll leave up the.
Amplified friends.
My Italian accent's That's how bad I am. This might be. All right, what's the circle thing?
Okay, so you grab one of those items, and grab a breadboard.
Fill it out.
I watched this.
Super high.
You have a pencil? Grab a breadboard there. Yes. we
Oh
do.
my god, you even have pencils?
I made Eddie buy them.
That's hilarious.
Yeah.
Thanks.
All right. Yeah. Take
Just
that.
like going to stay last year on the first day of school.
Just take a handful because you're not going to do it as efficiently as I did. Probably. I'll just take one of these. Oh, don't. Eddie's mad.
What'd you say? Who's
Eddie will
mad?
be mad.
Eddie will. Oh,
These are brand new.
great. That means I want them more.
Now they
It'll
go,
make Eddie mad.
now they go over here.
That doesn't mean anything. You are gonna need them. There's not enough here.
Excellent. That's very good. Okay, one additional little thing here. That programmable unijunction transistor from earlier, it's really easy to make with two transistors just like stuck like that in a breadboard. So you don't need to do a bunch of extra wiring. One of them is the NPN, one of them is the PNP. They have numbers on them. You have to look it up.
He said, give me the option, but you have
Grab a little out of that box.
Like a few of these.
Yeah, grab everything out of that box.
Oh, I see.
Oh, okay, nice.
Get it out.
Yes.
We will need jumpers, right?
Yeah.
Okay.
Yo, we got the.
Also need.
Oh, no.
I'm just waiting until the first person makes the.
What's the pin out of your amplifier?
What?
What's the pin out of your amplifier?
I'll entirely get.
The left side is brown. What's Wade's front?
Don't worry about it.
So that's.
So essentially, so you see how like there's this five or six left, and there's like
Yeah.
two like things.
What's the other side?
The other pin?
Yeah, one in the middle is the
It's like.
So it goes ground final.
the one on the very top is the. Yeah, I want to say that. It's a little hard. I think it's source and drain, but that's.
I think that might be, I remember hearing something about that.
But basically, voltage or current will only flow from 5 volt down past the arrow, and there is voltage applied to the middle one. And the portion of current, the amount of current proportional to the right side voltage applied to the gate.
I don't know, like, some people don't like rust, some people don't like performance. Yeah, I don't like it. That's the way it is.
Okay. So what do you go? Let me see.
What's going on? Nothing.
Absolutely.
Take all the things. Yes. Well, then it's like a little box. We don't know these for the same types. Yeah, they have like squares. So they didn't have much more. He said, actually, oh, you
Why did you just switch there?
I realized I
switched. Yeah, it's like the same person.
Oh yeah, you can be around. But I don't. Oh, I don't think. I think my fingers. I think my fingers are like. Oh, it's because of I think that's why it makes one downstairs. What was that? My performance power. Oh, like when you were doing this earlier? Yeah. Oh, that makes sense. I bet you would be hanging out down there. Like, oh, yeah. Yeah. Neat. If you like set it next to like, I play guitar, it's my amplifier, like if it's like a phone or an amplifier, I can hear myself sing
Oh, sorry, yeah.
I was trying to get the
Yeah.
I was trying to get the meeting stopped, but
Okay. What do we have so far? Now, when you connect, what do you think?